Consuelo, everybody. Okay, so what we did last time is polynomial division. That's really going to be used for something, what we're going to do later in the chapter. So today I'm going to do something totally different, and that is graphs of polynomials. Now, there's something I want to point out before we do this. Remember that a linear equation is a polynomial of degree 1. A quadratic equation is a polynomial of degree 2. Okay? We've already graphed both of those. You should know how to graph a line. You should know how to graph a parabola. Okay? So what I'm going to teach you today, will it work for a line in a parabola? Yeah, it will, but it's a bad way to graph a line in a parabola. It works, but it's just a bad way to do it. This is way too much work to graph lines and parabolas by. Okay? So this is really what we're talking about is polynomials of degree 3 or greater. So degree 3, degree 4, et cetera, et cetera. Okay, so the basic idea is this. We're going to determine end behavior, and that's what we're going to spend most of our time talking about. Alex refers to it as end behavior. I usually use the term extremes. So if I start talking about extremes, that's the same thing as end behavior. What happens at the ends of the graph? I'm talking about what happens like way out on the right-hand side of the graph, the right-hand end of it, and way out on the left-hand end of the graph. Okay, second, we're going to find intercepts, and you should know how to find intercepts. That's nothing new. We've been doing that for a long time. And then if you need to, you'd use a limited XY table to fill in any gaps of information. But quite frankly, you're not going to need to know that here because we're really just going to make sketches of graphs. We're not going to make really great looking graphs or anything. But you should just know that that's what you do if you wanted to make a better looking graph. But you can't graph these by an XY table. What I mean by that is you've got to do this by end behavior and intercepts. Okay, and you only notice I use the word limited XY table if you need to. Most of the time you don't need to. Sometimes you would, but again, we're not going to worry about that anyway. Okay, also you should know for a polynomial, when you draw a graph, it should be smooth. In other words, it should be curved, not pointed, okay? And also, it's continuous. There are no breaks in the graph. So there's nothing, it's not like it's going to look like this and then stop and continue like that or something. It just doesn't do that. It's just always going to be connected. Okay? Okay. Again, the main idea here that's new is going to be end behavior. I refer to this as the extremes. You want to know if the graph goes up, Alex calls it rises, or if the graph goes down, Alex calls it falls. To look at this, to figure this out, all you need to look at is the leading coefficient. Okay? The leading term. So to figure out the right extreme, you look at the leading coefficient, the number multiplied, okay, by the largest degree of the variable x. To figure out the left, you look at the degree. So, for example, what do I mean by that? Let's say you have 5x to the 12th and then the rest of the problem. Okay, this is the leading coefficient. You look at that first to determine what happens on the right. And then you look at the degree, the exponent, to figure out what happens on the left. And you've got to do it in that order, okay? All right, so let's see what happens here. It's not really that complicated of an idea, quite frankly. Okay, for the right extreme, the right goes up if you have a positive leading coefficient, and the right goes down if you have a negative leading coefficient. I mean, you already know that. I mean, think about a line. Y equals, but again, you don't want to use this for a line. I'm just trying to show you how you kind of already know this. 2x plus 7. Okay. What's this graph look like? It's a graph that goes up. Why does it go up? Because it's got a positive leading coefficient, right? And think of a parabola, y equals 2x squared plus 3x plus 1. That looks like this. The right goes up. Why does the right, you don't need to write this down, by the way, just listen. Why does the right go up? Because it's got a positive leading coefficient. Okay, now the left depends on the degree, the exponent, and what the right does. So let's take a line, okay? Its leading coefficient here, in this particular example that I've drawn, is positive, so the right goes up. On the parabola, also positive, the right goes up. If they had been negative, they just would have gone the opposite way. They would have gone down. Now, the left, okay, depends on the degree. So in other words, this is x to the first and this is x to the second. If it's an even degree, for instance, the parabola, then the left extreme does the exact same thing as the right. So since on the second equation here, it's an even degree, that one's going to go in the same direction as the right. If it's an odd degree, like in the line, the left's going to go in the opposite direction. Again, you don't want to use this for lines. I'm just trying to show you something you already know, so you can kind of see why this works. Now, what if, though, it's like y equals, and you don't need to write this down, just like negative 8 x to the 701st power, blah, 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 blah. Well, okay. It's negative, so the right will go down. But so that tells you what the right does. This tells you, since it's odd, that the left is going to go in the opposite direction, so it will go up. That's really about all there is to it, okay? What if this had been a positive? Well, then because it's positive, the right would go up. But because the degree is odd, the left would go in the opposite direction. Okay? Remember that the degree tells you like how many sides, this isn't like perfect, but it'll tell you how many sides there are to the graph. So if you think about it for a second, I'm going to get rid of this. If you look at the parabola, it's x squared, so there are two sides. And if there are two sections, sides, the left would always have to go the same way as the right. If it's an odd degree, there's going to be an odd number of sections or sides, and the left will always have to do the opposite of what the right does. Okay? And quite frankly, that's it. That's the only new thing I'm telling you. Well, no, that's not entirely true. But basically, that's the main new thing that I'm telling you. Again, you don't want to use this for lines or parabolas because there's just an easier way. But I just use those as examples to kind of give you something you're already familiar with. Okay. So keep in mind that an even degree tells you that the graph has an even number of sections. That's why the left always has to do the same thing as the right. And an odd degree means the graph has an odd number of sections. So the left always has to do the opposite, go in the opposite direction of whatever the right does. Okay. Again, I suggest you stop the video, do these two problems, sketch the extremes. All you got to do is, what's the right? What's the right do? Up or down? Alex uses the term rises or falls. What's the left do? Up or down? So I'm assuming you've, pause the video. I'm assuming you've already tried this on your own. Okay, so what's happening here? We're going to look at the right first. It's negative and it goes down. And then since this is even, the left is going to go in the same direction. Okay? This is positive, so it goes up. And since it's odd, the left is going to go in the opposite direction. Okay. Now, this whole thing on even and odd functions, go ahead and skip it. Okay? So, if we weren't so limited in class time, I would include it, but We are limited in class time. Okay, that's it. It's a pretty simple idea. Okay, now I'm going to have you go through a lot more stuff to kind of help you, but that's it. That's the main idea. What do? End behavior, whether the ends go up or down, find the intercepts. And then normally you would also, if we wanted to make a good graph, you'd make a limited XY table to fill in gaps in information. But we're not going to worry about that this year. Okay, have a good day, everybody.